is y equals plus or minus x a function? It looks like we're going to be doing a graph and a table. And what is the domain and range? So, main question is y equals plus or minus x a function? Let me divide it up. That way we have some order in this graph. Okay, so first of all, first check. If we substitute the -4 in place of the x in the equation y equals plus or minus x. So y equals plus or minus, and then we need a parentheses, a set of parentheses, I should say, with a -4 in the middle. Well, this means that we can split it up. Let's see, up first. We can split it up and say y equals a positive because of the positive in the plus or minus. And then we have a negative because of the number being a negative. So y equals plus minus 4. Well, that entitles a multiplication of fractions. Pardon me, not fractions, signs. And splitting up to the second portion, y equals the negative sign because of the plus or minus once again. And another -4 because of the fact that our number is negative. Okay, so first up at the top, y equals plus and minus 4. Positive times a negative. Keep in mind, if this gives you a hard time, I suggest or recommend reviewing multiplication of signs or multiplication and division of signs. So positive times a negative gives us a -4. Two different signs always gives us a negative value. While on the other hand, two same signs, in this case two negatives, negative times a negative, will always produce us a positive sign in multiplication and division. So there we go. We get two solutions. Y is -4 and y is +4. So let's graph this, but let's fill in our table. But first of all, let's remember to label our axis, x and y axis. So fill in our table, -4 and +4 is what we got from x is -4. And let's plot this. So there's one dot at x is -4 and up 4, and at x is -4 and down -4. So we have two dots in this case. Let's try the next case, -3. Y equals plus or minus -3 in place of the x. Notice that's where the parenthesis is, where our x used to be. And once again, let's split this up. So y equals plus minus 3 and y equals minus 3. The first positive and negative sign is because of our plus minus sign for our equation. That means we have two possible outputs or two possible outcomes. So positive times a -3, two different signs multiplied together gives us a -3. And negative times a -3, two same signs multiplied together gives us a positive. So in this case, we have -3 and +3 playing in our table. So when x is -3, we get -3 and +3. And let's plot them. X is -3, y is +3. And let's plot the next point. X is -3, y is -3. I should have done reverse order, but it still works. Okay, that just means that for our next graph, at x is -2, we're also going to get -2 and +2. So -2 for x and +2 for y, and -2 for x and -2 for y. Well, what happens when x is, well, -1? Well, it looks like it's going to be a similar case scenario. We're going to get a -1 and 1, and likewise we'll plot it at -1 for x, -1 for y, and -1 for x, -1 for y. Or pardon me. Okay, what happens when x is 0? Let's see, plugging in x is 0 into our equation, y equals plus or minus 0. Well, I do believe 0 is a neutral number. So positive times, well, a neutral number, positive times a positive, technically, still positive. Negative times a positive, well, 0 is neutral. So no matter what we do to it, it's still going to give us just a 0 number, or just a neutral 0. Okay, let's plot that one under. There it is. It's our origin. It's at the center of our graph. Okay, what happens when x is +1? So let's split this up. Unlike before, in this case, positive and a positive, positive. Negative times a positive gives us a negative. So it gives us y equals positive 1 and y equals negative 1. So it just gives us the reverse order of what we originally were getting. So let's plug it back into our graph, or first a table, then our graph. When x is 1, we get a positive 1 first, and then a negative 1, opposite order of before. And we plot them likewise on our graph. And when x is positive 2, likewise, it gives us a positive 2, and then a negative 2. And we'll plot them. There we go. Okay, so how about if we trace a line through those dots? It looks like we get a line here, and we get a line here. Hey, we get 2 lines, or 2 graphs, technically, out of one equation. So, what is the domain and what is the range? Well, this technically looks like it goes up forever and down forever, so our range would be any real number. And it goes to the left and to the right forever because of the arrows. So, any real number. So the domain, therefore, keep in mind the domain represents which variable? The x. You guessed it. It's the x variable. That is our domain. So therefore, the range is the y values. So all real numbers once again. Keep in mind we stated that earlier. So the domain, all real numbers, the range, all real numbers. So you can put any x value, whether it's positive or negative or 0, and you'll get any y value, meaning you can get any positive or negative values, including 0. And is it a function? Well, is this a function? Let's see. A function has only one output for every single input. Well, it looks like every single input has exactly 2 outputs, except for 0, which has only one input. So technically, the 0 would be the only place where it meets our function rule. So in this case, this is not a function because, well, we get 2 outputs for every input. Keep in mind the input.